I don't have a pointer. Anyway. All right. So the resource of today is about creatine metabolism, high energy phosphates, and muscle energy supply. So you know that the muscles, they are the only organ that they can transform the ATP or any source of energy into mechanical, we can say, activity, all right, muscle contractions, we can say, okay? And this muscle contraction, of course, it requires energy. It can be ATP and it can be also creatine phosphate, or we call it as well phosphocreatine. We will see how this ATP, it will be used, how it will be metabolized, what are the products of this metabolism, how they can help in the contractions of the muscles. And you will see as well how the creatine, it will be synthesized and how it will be degraded as well. All right. So the control, of course, of the muscle contractions, it is under the nervous systems. So the nervous systems is control the speed, the contractions, the duration of the activity, and also the return of to the resting states. Okay. All right. So what are the muscle types that you know? Skeletal muscles, cardiac muscle, and so we have three types of muscles, right? So we have the cardiac muscles, the smooth muscles, and the skeletal muscle. So the smooth muscles, at least we call them smooth because they don't have striations, all right? So as you can see here, there is no striation like in here. So they are very smooth, and this kind of muscles, they will find them, you know, on the digestive tracts and also in the vessels. However, for the cardiac muscles and for the skeletal muscles, they all have striations, so we call them striated muscles. And of course, for the skeletal muscles, this is the muscle that they cover our bones and will help us to move the skeleton, all right? Skeletal muscles, we can control. So, and it's under, you know, the voluntary nervous systems. However, for the cardiac muscles and for the digestive, the other one, we cannot control, so it's under the involuntary nervous system control. In terms of structures, I'm going to stay here. So in terms of structures, you can see that the muscle cells, they are structured in what we call a myofibril. It's kind of cylindrical fibers. All right, we call them myofibril, and they are embedded in kind of cytoplasm of the muscles. We call it sarcoplasm, right? And all these structures, they are surrounded by a membrane, which is called the sarcolemma. This is the excitable muscle membrane, all right? In the sarcoplasm, we're gonna find also molecules, okay, which helps for the energy supply. We can find ATP, we can find creatine phosphates, we can find glycogen, but we can find also the enzymes, which they will be involved in the glycolysis of the glucose or the conversion of your glycogen into glucose, okay? All right. For the skeletal muscles, we classified them in two types, type 1 and type 2. So this classification, it is based on the speed of the contractions and also for the ATP productions, all right? So the type 1, we call them the red muscles. You know, they are very rich in vessels, they have a lot of myoglobin in there, and they are very rich in mitochondria, all right? So when I said it's rich in mitochondria, so there is a productions of ATP, high productions of ATP. And this production بتصير بالميتوكوندريا by oxidative phosphorylations. Yes. اختلاف في شو في الهايلايت؟ It's okay, I just add them. I will download the new one if you want, but it's the same thing. So the large number of mitochondria, so this is what makes, you know, the high productions of ATP. And this kind of muscles, they are responsible for what we call the repeated contractions of low intensity. So when you go jogging, when you go for a walk, when you go in the bicycles, so this is the kind of muscles that you will be using, the type 1, because this one, they are, we can say, they contract very slowly and they are resistant to fatigue. Okay? The second types, we call it type 2, and it is subdivided in two types, 2A and 2B. So the 2A, they are red, the 2B, they are white. The 2A, they are very rich in vessels, على عكس 2A, okay? The 2A, it's rich in vessels, so they are pale red, على عكس the 2B, which they appear white, so they have very low level in myoglobin. For the type 2A fiber, they are very rich in mitochondria. على عكس type 2B, it is very few mitochondria exist. So as we said, if we have a lot of mitochondria, it means we have a productions of ATP by oxidative phosphorylations. So it's aerobic pathway. However, in this one, so we're going to have anaerobic glycolysis. So when we said anaerobic glycolysis is your conversion of your glucose into lactic acids, okay? And when someone say lactic acids, they say cramps. There is not sustainable contractions. We cannot have contractions for a long period of time. So the fatigue, it will occur very quickly. So this type of 2A fibers, they are used in the case of speed and strength. So when you have, for example, when you lift weight, but they have like medium weight, they are not really heavy. Okay, and however, for the type 2B, when it's heavy weight, and when you have a short sprint, like 100 meters sprint. Okay, so this is the kind of muscles. They can be used depending on the types of exercise, the types of the duration as well of the exercise and the intensity. So this table is just a comparative tables in which we summarize all the information that we said so far. You have the type 1, the type 2, the type 2B. So you have here red, white, slow twitch. Twitch yani contraction, okay? So slow twitch contraction, this is fast for glycolysis and lactic acid. So you have all the information, they have been summarized in these tables, okay? All right, yes? You have to memorize all the tables? No, you have to understand each muscle, what are their specificity, that's it. This table, it will help you maybe to memorize it, I don't know, because you have it, you have a comparison, all three together on the same table. So as we said, the energy used for the contractions, we have ATP. We have ATP in our cells, which are free in the cytoplasm, but also the muscles, they can use what we call the creatine phosphate. So how this creatine, it is synthesized. Creatine, our body, they can synthesize it by itself because we can synthesize it from two amino acids, which are arginine and glycine. So that's why we said it is not an essential element. The body can synthesize it, and even if you consume red meat, lahm, so it's very rich in creatine. But nowadays, people, they are consuming creatine as supplements, especially in the gyms, because it gives this kind of, bulk in the muscles. So it helps in building musculatures, okay? And it's a good source of energy. So as we said, the body can synthesize by itself الكرياتين starting from two amino acids اللي هما الارجينين and the glycine. So these two amino acids, they will combine in the kidney because the first steps it occurs in the kidney, and they will give us a component which is called the guanidoacetate. So this component guanidoacetate, it will travel to the liver. This is the second organ where the creatine synthesis it will occur, and where it will be methylated. And the donor of the methyl group, تعرفوا, is the SAM, okay, S-adenosyl methionine. So, and it will synthesize what we call the creatine, all right? Then this creatine, it will travel to the muscles, whatever, brain, heart, or whatever, which needs the energy. And this creatine, in the presence of ATP, so it will be converted into creatine phosphate or phosphocreatine. Okay, it will be phosphorylated, and as you can see here, this reaction, it is reversible, so we can also use the creatine phosphate to regenerate ATP. Okay, clear? All right, so you have to keep in mind also that as much as you have muscles, your body synthesizes creatine. Okay, it is proportional. We don't have the same amount, it depends of your muscle mass. Okay. All right, the creatine kinase, it's an enzyme which is responsible, as you can see in here. It is the enzyme which is responsible for the phosphorylation of your creatine into phosphocreatine or creatine phosphates, okay? So in our body, we have three types or three isoenzymes of creatine kinase, and the difference بيناتهم is just the locations. Okay, so once it is in skeletal muscle, we call it CKMM. The one in the heart is CKMB, and the other one in the brain is BB. Okay, so all these creatine kinase, they can be used as biomarker for any injury, you know, muscles injury, heart injury. For example, when you have myocardial infarctions, so the CKMB, it will increase. All right, so it can be a diagnostic tool for any, you know, chronic muscles or acute muscle disease. Okay, واضح? All right, so we talked about creatine synthesis. Now we're going to talk about its degradations. All right, so this creatine, it will be very quickly, it can be metabolized and it can be converted, as you can see here in the pictures. It will be cyclized and it will be converted into creatinine. So the creatinine, it is the waste product of creatine, and the body cannot metabolize further, it cannot degrade further the creatinine, so this is why we find the creatinine in the urine. It will be excreted by the kidney in the urine. And as we said, as much as we have muscle mass, we produce creatine, but also we produce creatinine, because the creatine كلها, it will be converted into creatinine. Okay, it's clear? All right, so definitely when you have, for example, any muscles problems, or when you have a decrease, for example, in case of paralysis or dystrophy, muscle dystrophy, so of course your muscle mass, it will be decreased. So definitely your creatine, it will decrease, and your creatinine as well, it will be decreased in the urine. So that's why the creatinine sometimes, not sometimes, it is used as a diagnostic tool for the kidney functions. So when you test one of the kidney parameter, you ask for creatinine. Why? Because usually when the creatinine, it is excreted in the urine. All right, so when there is any impairment of the kidney, so this creatinine, it will not be excreted, so it will stay in the blood. So its level in the blood, it will increase. So that's why when we measure the creatinine with القاعات, so there is a problems in the kidney, there is kidney malfunctions. Okay. All right, the second types of, you know, energy supply, we said it's the ATP. So we have molecule of ATP in the, we can say in the sarcoplasm, that can be used by the muscles for muscle contractions. So this ATP, you know, it will be hydrolyzed, can be converted into ADP, right? And this ADP in return, it can be rephosphorylated, and we can obtain again the ATP, all right? But it can be also this ATP, it can be also converted into AMP by dephosphorylations. Okay, so this AMP, it can be deaminated, so we're going to remove the amino functions, so it will lead to the production of ammonia, right? You remember that last year? No, you forgot it? The ammonia production, urea cycle. You forgot that? All right, so the AMP, when it will be deaminated, so we're going to obtain the ammonia, and this is ammonia. It can be a source of from the muscles, Or the AMP, it can be dephosphorylated. We remove the phosphate group, and this phosphate group we obtain what we call the adenosine. And this adenosine, it is a vasodilator, and it is very important to increase the blood supply in the muscles. Okay, so this is to show you how the ATP metabolite, ADP, and AMP, they can be used, even though it's not ATP, they can be used for the muscle contractions. Okay. You repeat what?
ATP to ADP, then ADP to AMP, then?
So ATP, it will be hydrolyzed, it will be consumed during contraction, muscle cell contraction, and it will be converted into ADP. All right. So this molecule of ATP can be rephosphorylated, and we can regenerate ATP. Or it can be hydrolyzed more ونحصله على ال AMP. Okay, adenosine monophosphate. This adenosine monophosphate, it can be deaminated, where we're going to remove the amino groups. So this leads to the formation of ammonia. Or it can be dephosphorylated. We remove the phosphate group ونحصل الأدينوزين. And this adenosine, it is a vasodilators components. It's clear? All right. So now we're going to talk about what are the energy systems which are used by the skeletal muscles for the energy supply. So we have in our body 3 types of energy systems, and we can set the choice of these energy systems. It depends on the intensity and the durations of the exercise or the training or whatever, the activity in general. So the immediate energy, as you can see here, this is the ATP, and you have the phosphatogen systems, which is the phosphocreatine. All right, then it will be followed by what we call the anaerobic glycolysis systems and the production of lactic acids. And the long term, we can say energy supply, it is the aerobic glycolysis systems and also lipolysis. Okay. So, but you keep in mind that in our body, all these 3 systems, they work all together, all right? There is no, you can say, one working and the other one, it is in resting state. So all of them, they were working together. It's just one, it is predominant over the other one, okay? So the first one, which is the immediate one, which is the ATP and the phosphatogen systems. So this one, it doesn't last more than 10 seconds. Okay, so this is for activity like 100-meter sprint, 25-meter swim, smashing a tennis serve. So it's very, very quickly, it's very hit, it needs quick, you know, and available energy, all right, very quickly. So this is, we can say, the ATP and the phosphatogen systems. The second one, which is the anaerobic glycolysis, which is represented here in yellow. It doesn't last more than 1 minute, and it is performed when you have a short duration, high and high intensity. Short duration and high intensity. So, for example, when you have 400-meter sprint, 100-meter swim, or multi-sprint sport. So this kind of, we can say, exercise, we use anaerobic systems, so it will lead to the formation of lactic acids, and the lactic acids, it can be reconverted into glucose by the Cori cycle, which is in the liver. All right, the Cori cycle can regenerate, you know, and retransform your lactic acids into glucose and send it back to the muscles. So the last one, which is the aerobic energy system. So this one is for medium to low intensity activity. It's the one which lasts more than 2 to 3 minutes exercise, and in which we're going to have glycolysis breakdown. We're going to have conversion of your pyruvates into acetyl-CoA, and this acetyl-CoA will enter in the Krebs cycle and will generate your ATP. Same thing here. We're going to have lipolysis, and we're going to degrade, we can say, your fatty acids by beta oxidations, and we're going to enter, we synthesize acetyl-CoA, and this acetyl-CoA, it goes into the Krebs cycles. Okay? That's it. Do you have questions? Clear? All right. Thank you very much.